Achha, look at this question number 7. It says at 1200 hours, a tanker sails from a point P with position vector this. Now we're given the position vector, okay? Relative to an origin. The tanker sails southeast, okay? The tanker is going towards southeast. Suppose here is your southeast किधर होता है भला एक second. We have here we have north, this is the south, this is the east, and this one is the west. Okay, so the tanker is exactly going in this direction, southeast. Remember, southeast means at a bearing of 135 degrees. Okay, now stay alert, bacho. So suppose this was the position of your tanker, that was OP, and here it is your O. Okay, and the tanker is going in this direction. This time we don't have the velocity vector. He is in fact asking for the velocity vector. Velocity vector. Okay, let's do that. A good student can always switch between the vector form and then the scalar form. Now, suppose you have a vector, like suppose you have a vector AB, AB, which is 3, 4. Okay? Now, by looking at this vector 3, 4, you can say, okay, if it is, if A is here, this is 1, 2, 3, 1, 2, 3, 4. Okay? So that means this is the direction AB. Okay? This is the direction AB. Acha, now this is the vector form. You can take out the magnitude from this. You know that if you find the magnitude of AB, that is this square plus this square root, you will get that as 5. ठीक है ना? That is 5. If you try, you can give its exact direction as well. Look at this. You people know that this is 4 here, this is 3 here, okay? And if this is theta over here, you can say, well, I have tan theta equals 4 over 3. And if you use your calculator, you can have this as 53.1. I think, please find that. I'm doing that mentally. I don't have the calculator around. What is tan inverse of 4 over 3? Is that
It's
53?
51, 53.1.
Okay, thank you very much. So you see,
फिर ये आपको कैसे आता था?
hmm?
How did you do that mentally?
Oh, because I have been doing this for ages. You see, this 3, 4 is a typical vector. So don't be impressed, okay? So I just remember this because this 3, 4 is used a lot. Okay? Acha bacho. Now, we had a vector, we converted that into the magnitude and into the direction. Now suppose people, someone says, look, I have a vector whose magnitude is 5 and which is its direction is 53.1. Okay, or you can give you the bearing. It is going at a bearing of 053.1. So you can roughly draw this. You can say, okay, I think sorry, this should not be the bearing here, so because bearing has to be from the north, so since it has to be from the x-axis, so this angle is 53.1. Okay, and he says, give me the vector which has a magnitude 5 and which is inclined and at a direction of 53.1. So no problem, bacho. This is your x, this is your y. Okay, na? Can I say this x is going to be 5 cos 53.1? Say yes or no. Hurry up. If you do that working, bacho, can I say cos
Sir, you can.
3, yes, but 53.1, that is going to be x over 5, and this x is going to be 5 cos 53.1. The poor only maths people will do this step, okay? And you cool add maths people, you know that, this is the adjacent side here. So it has to be cos of this 5 cos 53.1. And this would be 5 sine 53.1. And you can say, look, that vector whose magnitude is 5 and the direction is 53.1, that vector is basically 5 cos 53.1, 5 sine 53.1. You have to tell me if you understand this or not. A little recap here. If you have a vector, you see this 3, 4, you can take out its magnitude and its direction. And then if you have the magnitude and direction, you can put this Jenny back into the bottle using all these methods here, okay? Now, let me give you some more examples here, okay? Now suppose, bacho, you have a vector whose magnitude is, suppose there's a vector whose magnitude is, let's say 10, okay? And it is going in the direction, let's suppose it is going in the direction here, okay? This is going in the direction of 120 degrees, okay? So you have to tell us that what is this vector? Suppose this is the vector A. So you have to give this vector A whose magnitude is A, sorry, 10, and which is going in this direction. Okay? Acha. Let me give you in general that if you have the magnitude, suppose there is a vector whose magnitude is R and whose direction is theta, okay? Where theta is a general angle. If theta is a general angle, if you use the general angle, you will not have to be worried about the directions, okay? If theta is a general angle, then then the vector AB would be R cos theta, R sine theta. This is not a rocket science, bacho. Look at this. If this is your R and if this is your theta over here, don't think we are doing something very difficult. Now this one is going to be R cos theta and this one is going to be R sine theta. So just give a slap to yourself, because some of you might be thinking, "Hey, yaar, kitna difficult hai yaar, ye to kabhi zindagi mein dekha nahi tha." It is not at all like that, okay? So you can simply say that this vector whose magnitude is 10 and which is going at this direction 120, this vector is basically going to be 10 cos 120 and 10 sine 120. Achha, just 1 minute before you use your calculators, bacho, what do you think? What should be the x coordinate of this vector? Should that be positive or negative? Hmm?
Negative.
Negative.
Negative, है ना? And what about the y component? Would that be positive or negative?
Positive.
Positive.
Positive. Achha, you will see that you use your calculators. Tell me quickly. 10 cos 120 would be -5, I think, है ना? And 10 sine 120 would be 5 under root 3, something like this. देखना जरा. Is it like this?
Yes, sir. Yeah, yeah.
है ना?
Understood.
अच्छा. So this is the vector whose magnitude was 10 and whose direction was 120. Now suppose if someone from you says, "Can I yaar, mujhe nahi, main, I don't want to use this 120," okay? Then that girl would have to determine this angle first. She would have to say, "Okay, this angle is 60. And I know that my x component will be negative and my y component would be positive." So she would write it as this magnitude is 10 here, by the way. This is minus 10 cos 60, and this one is 10 sine 60. Okay. So if you use the basic angle, you will have to predetermine the sign of this component. And if you use the general angle, you will not to be worrying about that what would be the sign of the x component and what would be the sign of the y component. Acha. Now look at this one more example. Suppose there is a vector which is going in this direction, okay, in the
Sir, I
x.
don't get the.
What did you not get, beta? Hmm?
Sir,
Chale,
why
abhi.
did you? Why was 60 like the general language?
Oh, bete. Now don't tell me that I'll have to go back to the trigonometry. Yaar. If this is your 120, then what would be the basic angle here? Come on. If you go up to this, wouldn't this be 180 degrees? Hmm? Come on.
Okay, I get
Ah.
it.
Acha, 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 acha. Okay, now look at this. Suppose there is a vector going in this direction. It has a magnitude 5. Can you tell me quickly what is this vector which is going in this direction and has a magnitude 5? Please tell me quickly. Hurry up.
3, 4.
Oh, 3, 4. This is simply 5, 0. This is 5, 0. Okay. Now suppose you challenge me कि सर आप कह रहे थे कि इससे तो मिल जाता है r cos theta, r sin theta से. Look at this. What is the angle it is making with the x-axis? What is its general angle here? Hurry up.
180 degrees.
Oh, come on, yaar.
90, 90,
Zero.
90, 90, sir, 90.
Oh,
Sorry.
it is 0.
0. Okay, yes.
Oh, गोलियां मार दूं मैं तुम सारे लोगों को यार. This is 0 degrees. This is going in 0 degrees direction, beta. So this would be r is 5. So this is 5 cos 0, 5 sin 0. What is cos 0? Hmm? Oh God,
Zero.
this is
One.
55 main students. Oh, cos 0 is 1 and sin 0 is 0. So therefore, this is going to be 5, 0. So you could have written this mentally here. Now suppose there is a vector going in this direction. Now suppose this magnitude is 3. What would be this vector if this is a right angle over here? Hmm? This is a right angle here. So tell me mentally first. Hmm? Hurry up.
03.
Zero.
Zero
Three.
three. Very good. Very good. This is 0, 3. Now we can write this vector using this method here. The magnitude is 3 and the angle is 90 degrees. So this would be 3 cos 90 and then 3 sin 90. And you know that cos 90 is 0, sin 90 is 1. Therefore, this is going to be 0, 3. Now look at this. There is a vector here. Suppose its magnitude is this is minus 7 here. The magnitude is 7. And now you can see that this angle is 180 degrees. First, tell me without any working, what would be this vector, which is going in this direction here?
Minus 7 and 0.
Very good. That's like the 55 mainers. That is minus 7, 0. This is minus 7, 0. Well, let's use this method to determine this. Can I write this as the magnitude is 7 and the angle is 180? 7 cos 180 and then 7 sine 180. What is cos 180?
-1.
Yeah, so this is minus 7. Sine 180 is 0. This is minus 7, 0. So you're getting the same with the working, without the working. Just one last thing. Suppose you have a vector here at minus 2 and it is going in this direction. So first tell me mentally what would be this vector here. Hurry up.
0 and
0,
minus 2.
-2.
Oh, very good girls, mashallah. 0 minus 2. And suppose if I want to find this through this jiggers method here, this r cos theta, r sin theta. So what should I do now? Yes. So that would be,
-2 cos
don't say
270 is
minus 2. No,
zero.
no, 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 no. The magnitude is always positive. This is 2 cos 270 and 2 sine 270. And we know that cos 270 is 0. It's going to be 0. Sine 270 is minus 1. This is 0 minus 2. That is your vector, which had a magnitude 2 and going in this direction towards the west here. ठीक है बच्चों? So going back to the question now, I just want to sum this up now. You can go through these videos again and like, this is all up to you now. How much you practice this? Okay. Now let me complete this question number 7 and that will end our chapter. Acha bachcho, it says at 1200 hours, a tanker sails from a point P with position vector this. Now, can I say that the the tanker is going in this direction here? Its magnitude is 12 under root 2. Okay. And this angle over here, because I know that southeast is a bearing of 135 degrees. By the way, there is a playlist on the bearings as well. We have covered that here. So this is 135 degrees, Hannah. That is southeast. This is your east here. This is your south here. So this angle is 45 degrees. Now, there are two kind of people here. One who would like to use the general angle. If you want to use the general angle, you will not have to be worried about the directions. If you want to use this basic angle, choice is all yours, but you will have to predetermine the sign of this direction. Suppose you want to use this 45 degrees instead of all of this 315 degrees, है ना? तो बच्चों, let me do it with both ways. Now, you know that the velocity vector is going to be r cos theta, r sine theta. Now, should I use the basic angle or the general angle? Tell me quickly. Hmm?
Basic.
Basic angle.
Okay, the basic angle. Okay, if you want to use the basic angle, then you will have to write it as 12 under root 2 cos 45. And with this, you will write a minus because you know your y coordinate is going downwards. This is minus. This x is positive, y is negative. This is minus 12 under root 2 sine 45. How many of you remember the value of sine 45 and cos 45 mentally? Hmm?
1/2.
1 over under root 2. 1 over under root 2.
1/2.
Okay, so this will be left with 12 minus 12. This is the answer to this first part here, the velocity vector. I'm telling you, this question is going to be there in your final exams, so you better prepare this.
Sir,
Yes, yes, yes.
sir,
Yeah.
how do we determine the angle is 135? I didn't get that.
Oh, that means your bearings are weak, beta. Bearings are weak. Let me tell you quickly the typical bearings. If you're going due east, what is your bearing? Tell me quickly. Hurry up.
180.
Oh, that is going to be 90. Oh, sorry. That is really 90. I thought you would say. Acha. And if you're going towards the west, what is your bearing?
90.
180.
270.
No, 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 beta. This is a
Who is
clockwise
the
angle. This is a clockwise angle from the north. Okay, so that is why your east bearing was correct. This is your south here. Okay, due south. That is going to be 180 degrees. Okay, and then when you go towards the west here, this is west. Okay, so that is going to be a bearing of 270 degrees. And if you are going towards the north, so that is either you call this 360 degrees or 00 degrees. Remember, we write this in three letters, three digits here. Okay. Um, this bearing, which is northeast, northeast means exactly between north and east, and that is going to be a bearing of 45 degrees. When you people are going southeast, that means okay, this is absolutely between the east and south. So this angle is 45 degrees. Therefore, this bearing is going to be 135 degrees. Just to sum this up, if you people are going southwest, so this means this angle is going to be 45 and this bearing is going to be 225. This southwest is a bearing of 225. This southeast is a bearing of 135. And one last thing left here, if you guys are going northwest here, so this is your 45 here. So northwest is going to be 315. Okay. So that is why, bacho, we have taken this as 135 degrees. Got it? Hmm?
Yes, sir.
Yes,
Yes?
Yes,
sir.
thank you.
Acha mere bacho. Now it says find, we have done this. We have got the velocity vector. It says find the position of the tanker at this, at this. Now, can I write this position vector in general form if you people allow me? Can I write this as OPT is going to be, it was initially at 512, Hannah, and this is going to be T times 12 minus 12. When it says at 1400 hours, so you put this T as 2, you will get to that answer. So for B part 1, you put your T equal to 2. And for B part 2, you have to put your T as what? Tell me quickly. 1245. How many hours later than 1200 hours?
0.75.
Very good. Jeet.
45/6.
Or you can say 3 over 4 hours. Okay, so you put your T 3 over 4, you get to the answer. This it says find the position of the tanker T hours after P. We have already done this. This is the answer to the C part. Okay, bacho, I hope you will practice this and inshallah you will master this concept. Okay. Okay, we have an examination question here. So it says at 12 hours, a coast guard at point O observes a ship with position vector this. Okay, uh, with position vector this, and relative to O, this the ship is moving at steady speed of O. So we have to pick this up 10 kilometer per hour on a bearing of, this is what I have to do. The rest, I believe you people can do that. Okay. Acha. So guys, initially our ship is, suppose this is O and here is P. Okay. This is 1612. Okay. Now it says the ship is moving at a steady speed of 10 kilometer per hour on a bearing of 330. We should be very clear at the bearing. Okay. Now, this one is, here it is 0, this is 90, this is 180, this is 270 and plus 60. So this is the bearing of 330. It means the ship is going in this direction. Let me draw it here. I'll draw that later. Okay. Now its magnitude is 10, and all of this is going to be 330 degrees. Okay. The ones who want to use the basic angle, they would say, okay, this angle is 60 degrees. Okay. And they know that their x component would be negative because this is going towards the left, and the y coordinate would be positive because this is going to go up. Is that fine, bacho? Can you relate to this?
जी सर.
Yes,
है
sir.
ना? लो बच्चों. So part A, we have to write the velocity vector. The velocity of this, what is the letter is given? Q or P? Okay, let me write this velocity of P. So that is going to be minus 10 cos 60. Remember cos 60 half hota hai, theek hai na? And this is going to be 10 sine 60. And sine 60 hota hai under root 3 over 2. Okay. So when you simplify this, you will get minus 5 under root 5 under root 3. 5 under root 3. That is, you better keep this in exact form rather writing this in decimals. So this is the velocity vector. Therefore, the value of this P is going to be 5 under root 3. Is that clear, bacho? Hello?
जी सर clear है.
Yes?
Yes, sir.
Okay, bacho. It says write down in terms of T the position of the ship relative to O. T hours after 1200 hours. We are good players of that now. Part B's answer would simply be, this is going to be OPT, that is 1612, the initial position, plus T times minus 5 under root 3. Okay. It says find the time when the ship is due north of O. Due north of O.
सर
When it
OP
is,
के ऊपर वेक्टर वाली लाइन लगानी होगी.
Mhm.
Do we have to put like a line over OP
Yeah,
to
I
show
think you
that?
should do that.
Thank you.
You should do that. Okay. Okay. This is the initial position here. Okay. And your north is like this, Hannah, and this is your east-west key line. Now, our ship is going, let me show the bearing here as well. If I draw that east, west, north here, the ship is going in this direction here, Hannah, because this angle is 60 degrees. He's saying that what is that time when the ship is due north of this O, okay? So since we are determining all the coordinates from O, and there is a north at O, that means indirectly he is talking about the y-axis. That when this line of this track cuts the y-axis, so that means indirectly you have to put x equal to 0 in your OPT, है ना? So when you put your x equal to 0, बच्चों, ओए बच्चों, 16 minus 5t, that would be equal to 0. So 5t equal to 16, t is equal to, I think that is 3.2. Okay. 3.2 means 3 hours and 12 minutes. Hai, so that is going to be 3:12 p.m. This will be the time when the ship will be due north of O. Okay. Got it? Bachcho, jaldi batao.
Yes,
Hello.
sir.
And now it says, find the distance of the ship. No problem. You put this t um, um, into this equation here. Okay. So you will get to that position, and then you can find that distance here. Suppose this point is Q over here. We know that the x component is 0. and just put this t here. So this last part, d part, your OP would be, I can simply write 0 here. Please quickly multiply 5 under root 3 with 3.2. Hurry up. And 12, add 12 into that. 12 plus 3.2 times 5 under root 3. Tell me, what do you get?
12 plus 16 under root 3.
What, beta?
12 plus 16 under root 3.
12 plus 16 under root 3. Okay, so this is 0. So the distance is going to be, this distance is 12 plus, you could have got that into the decimals as well. So anyhow, this is the distance at that time when it is due north of the point O. So guys, our session on add mass vectors ends here. So let's see you in the next topic, inshallah, very soon.